Hello and welcome. Today we're looking at hydration of alkynes. Hydration basically means you're adding water, that's H and OH, across the triple bond. And this is presented by science visualized. So if you look at this alkyne here, I've labeled the first carbon as A, and then B, C, and D. The alkyne carbons are A and B. If you look at carbon number A, it actually has one hydrogen, while carbon number B has no hydrogen, so zero hydrogen. When that reacts with water in the presence of an acid, any type of acid, the result will be hydration. So basically you'll be adding H and OH across the triple bond, and that's Markovnikov addition. And remember Markovnikov, H adds to the carbon with the most H. So when you look at our example, the carbon with most H is this carbon here, has one hydrogen. Now that's the hydrogen. Is this carbon here, which has one hydrogen. So hydrogen will add to that carbon, labeled A. And then the OH will add to the other carbon, that's carbon number B, so that one there. And you end up with that product, but that product is not stable because you have an alkene. You have an alkene right there, and an OH connected to the alkene carbon. So that product has an alkene and an OH, and because it has an alkene, we use the last part for the alkene in, and then the alcohol, the last part is ol. So that's called an enol. And because it's not stable, it will go through what we call K.E.T. That's Keto-Enol Tautomerism. So that means it's going to change to a keto format. And the keto format is this alcohol or OH will turn to carbon double bond oxygen. So basically that alkene electrons will flow there, and you end up with a double bond in the, at the OH position. So you end up with at carbon number B with a double bond like that. So that's called Keto-Enol Tautomerism, and the product is a ketone. Now, if we carry out a similar reaction, again starting with the same alkyne, that one, but now we are using BH3, sodium hydroxide, hydrogen peroxide, H2O2, and water, you'll end up adding H and OH, but now it will be anti-Markovnikov. Anti-Markovnikov addition involves addition of this hydrogen to the carbon with the least hydrogen. And we saw in the example before, carbon B has least hydrogen. So that carbon has least hydrogen. So you end up adding the hydrogen there, and then we still have the double bond. And then we add the OH to the other carbon. So you still end up with an enol, just like we saw before. And then that rearranges through Keto-Enol Tautomerism. So K.E.T. We draw the arrow going to the right to the ketone format to be longer than the one going backwards, meaning there's a ketone, meaning that the keto form is more stable, it's favored. And basically what happens there is that now that double bond moves here and it becomes double bond to that oxygen. So this product is actually an aldehyde. So we see that with anti-Markovnikov addition, you end up with an aldehyde as the favored product, the keto form, while Markovnikov addition gives you a ketone. If you enjoyed this presentation, please support the channel by subscribing. Thank you.